Hi, so for part 2 of our class tonight, we have our assistant Midnight here to help us out. And in part 2, we're going to look at an example that reads, a coal mine's rate of production is f prime of x is equal to 100 e to the negative 0.1x tons per day. What is the total coal production from day 2 to day 7? Now, this might sound familiar to you because this was the example that I opened our last class with, and then I told you what the final answer was. And I kind of left out a big part in the middle of, Diane, how did you know that the final answer is 322 tons of coal? So what we're going to do now is go through the details of where that number came from. All right, so what we're given here is we're given a rate of change. So that as soon as I see the word rate, in this case rate of production, that means that this function here is a derivative. It's a rate of change, and so the area under this function is going to tell us about production. Okay, so the total coal production from day 2 to day 7, we want to talk about area under this derivative between day 2 and day 7. So the first step that we want to do is that we want to graph this function. So we're going to go over here to our graphing calculator, and we will type in our f prime of x, which in this case is 100 e to the negative 0.1x, and then we are interested in days 2 through day 7. Now, I think, when we had the picture before, we started with day 0, so it doesn't really matter if you just do day 2 to day 7 or if you include some days around that. I'm going to do from day 0 to day 8. Okay, so once I've chosen my x minimum and my x maximum, then I go to Zoom and scroll down to Zoom Fit and hit enter. Okay, cool. So here is our graph. Now, once I get the graph, I like to go back to the window again. And what I notice on this window is that our y maximum is 100, which means that on this graph, this highest point up here is 100. But our y minimum is 44.9 stuff. And so that means that on the graph we have right now, we are not showing the x-axis. I'm going to change the y minimum. Hi, Franklin. Franklin says hi. Say goodbye, Franklin. Okay, we want to change our y minimum to be y equals 0. That way we can see the x-axis. So now we'll go ahead and graph again. And here's our picture. And if you remember the graph from our last class, then you will recognize that this looks kind of like that graph from before. Okay, so now that we have a picture, let's draw this up on the board. Okay, so trying to draw this picture kind of looks something like this. And this is the graph of y equals f prime of x. And along the x-axis, x represents, well, let's see, x, what is the total coal production from days 2 to day 7? And when we're talking about tons per day, this x is representing number of days. So we have 1, 2, 3, 4, 5, 6, 7, 8. And on the y-axis, that is our rate of production, and that is measured in tons per day. And our highest value, what we saw on our graph over here, excuse us, Franklin. What we saw on the graph over here was that this high point up here was a y value of 100. So I can mark that as my top value up here. And so this says on day 0, in other words, when we're first starting to count this production, the rate of coal production is 100 tons per day. From there, our graph is decreasing, which means, that does not mean that we have less coal being produced in total, but what it does mean is that the amount produced per day is decreasing on each day. Okay, so here's our picture. And we want to know the total coal production from day 2 to day 7. So I'm going to mark day 2, draw a vertical line, day 7, draw a vertical line, and we would like to find this area under our function between day 2 and day 7. And that area represents the total coal production from day 2 to day 7. All right, now when I first introduced this problem to you in last class, I said, and it turns out that the area is 322. Well, we're going to actually find that number. So to calculate this area, the area under our function between 2 and 7, we're going to find the definite integral from 2 to 7 of this function, which is our derivative function, 100 e to the negative 0.1x dx, and this is going to tell us our total coal production. Total coal production from day 2 to day 7. So we want to evaluate this definite integral, the integral from 2 to 7 of 100 e to the negative 0.1x dx. So the first thing that I do to evaluate a definite integral is that I want to ignore the bounds, and I want to evaluate the indefinite integral, which means erase the 2 and the 7, and we have the integral of 100 e to the negative 0.1x dx. And when I look at this function in the middle here, what I notice is I have an exponential function, but the power up here is fancier than just an x, which means that I'm going to want to do a u substitution, and my choice for u is going to be that exponent, so negative 0.1x. So that's my choice for u. The steps that I take are that I take a derivative. The derivative of u is du over dx. The derivative of negative 0.1x is negative 0.1. And now I want to solve for dx. So to solve for dx, I first multiply both sides by dx. And I get du is equal to negative 0.1 dx. Divide both sides by negative 0.1. And we have that dx is equal to du over negative 0.1. Okay, so that's my work off to the side, and now I can make my substitutions. So I have the integral of 100 e, I replace the negative 0.1x with u, so I have e to the u, and I replace dx with du over negative 0.1. All right, so now that I've made the substitutions, I ask myself, are there any x's that I need to cancel? In this case, the answer is no. I've gotten rid of all of the x's, but I do want to clean up by moving this negative 0.1 to the front. And what that's going to leave us with is I'm going to have 100, so in here I'll have 100 divided by negative 0.1, because that negative 0.1 has to stay in the basement. When I crunch that in my calculator, this gives me negative 1000 e to the u du, and I still have the integral sign in the front. Okay, everything is in terms of u, and I have simplified all of my numbers. Now I'm ready to take my antiderivative. And I know I've said this before, but this is the most important step, so you definitely want to remember to take your antiderivative. This is the most forgotten step in doing a u substitution, and that's the whole point of doing a u substitution, is finding this antiderivative. Okay, so here we go. We're going to take our antiderivative. Now, when I look at negative 1000 e to the u, I just have a regular variable up here, so I'm all set with my u substitution. My antiderivative of e to the u is e to the u. So I carry along the number, negative 1000. Take the antiderivative of e to the u, which is e to the u, and then I have a plus c. So it looks like I've done nothing, but I actually did. I took an antiderivative. Now that I've taken the antiderivative, I resubstitute for my value I chose for u. So we have negative 1000 e to the negative 0.1x plus c. Cool. So this is our antiderivative, our capital F. And we now want to plug in our top and our bottom numbers. So we want to evaluate f of our top number. So capital F of 7 will be negative 1000 e to the negative 0.1 times 7. And you should check this in your calculator, but what I got when I typed this into my calculator was negative 496.6. And then we plug in our bottom bound into negative 1000 e to the negative 0.1x, but our x is 2. And what I came up with when I typed this one into my calculator is negative 818.7. Okay, so we plugged our top number and our bottom number into our antiderivative. Now we're going to subtract. So f of the top number minus f of the bottom number is going to be negative 496.6 minus a negative 818.7. You want to be careful here because we have a double negative, so this really becomes a plus sign. So now we have negative 496.6 minus a negative 818.7, and when I crunched that on my calculator ahead of time, I came up with 322.1. Okay. So what that tells us is that this definite integral up above is equal to 322.1. That means that the area under our derivative function between x equals 2 and x equals 7, that area is equal to 322.1 square units as a shape. But in terms of the meaning of our problem, let's think about what the label is going to be on this number in the context of our problem. Our label, well, we have area, so that's like a base times a height, or a width times a length, or a length times width. It doesn't really matter how you think about it. But we have our horizontal label of days. So it's like our base times our height, and the label on the y value is tons per day. And so when you have days times tons per day, the days will cancel, and you'll be left with tons. So the label on our number, on our 322, is going to be tons. So our final answer in this problem is that the total amount of coal produced from day 2 to day 7 is 322.1 tons. Okay, so we finished evaluating this integral by hand. It might be nice to double check this on the calculator, and we've already graphed the function, so this is actually a pretty quick check. So let's go back over to the graphing calculator for a minute. And again, we have our function here. This is our derivative, our 100e to the negative 0.1x. And if I go to second and then calc, which is right above the trace button, then number 7 on this list of options is the integral, and so I want to pop down to there and hit enter. And this asks me for a lower limit. Now our lower bound, the bottom of the stretched out s, the bound was a 2, so I'll plug that in. By the way, it is important if you are graphing, that you make sure that you include, for example, here we're going to go 2 up to 7. Make sure that both your lower and your upper bound are visible. If you don't have those values as part of your graph, the calculator will yell at you. Okay, so our lower bound is x equals 2. Our upper bound is 7. And we are now told that the integral, in other words, the area under our function from 2 up to 7 is 322.1. Okay, so our last video, we will look at one final example of using definite integrals.